Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. And in today's lecture, we'll be starting with the new concept, which is moment generating function. And in short form, it is also known as MGF, moment generating function, or it is also known as MGF. So this is moment generating function. Now, what is moment generating function? If we say about that, we have it is denoted by m with the variable x and t. Moment generated function is nothing but expectation of e raised to the power tx, which when written can be written as from minus infinity to infinity e raised to the power tx fx dx when x is a continuous random variable. And it is equal to summation over x e raised to the power tx px when x is a discrete random variable. It simply can be derived from expectation. When we know the laws of expectation, it can be derived from here. Now there are some properties of MGF, which is moment generating function. You should be knowing that even if the moments, from the term itself, moment generating function, it is said that the it generates the moment of a variable. Suppose we have x variable, then it generates the moments over the about the origin, which is mu1 mu2 up till mu n. So from the term itself, even though for a variable moments may not exist, MGF will always exist. That is one of the properties. Now some mathematical properties of moment generating function is, if they have given us m, c, x, t, where c is any constant, then we can write it as mx of ct, which becomes equals to uh, a moment generating function, where c is a constant. Now, moment generating function is not independent of change of origin and of scale. So, if we write it as m x minus a upon h t, then it can be written as x minus a upon h m x t upon h. And this is nothing but exponential e raised to the power minus a upon h. It becomes like this. If we have two independent variables x and y, then mx plus y t can be written as mxt into myt, where x and y are independent, identical and independently distributed. IIDs, where x and y's are IIDs. There is one more derivation or one more formula for calculating MGF or the moments, which is, if we say that we have to calculate mu r dash, then it should be equal to in differentiation, rth differentiation with respect to x of mx t, which is nothing but t equals to 0. And mu r dash is nothing but estimation expectation of x raised to the power r, which is nothing but this only. This is your modulus. So these formula we'll be using in today's question. We'll be doing some PYQs and some more questions of on moment generating function. Let us see. First of all, they have given us these questions, and they have told us how many statements are correct. Now here they are independent and identical, then only they can be termed like this. So here the first statement says that x and y are identically distributed, then mxt equals to myt. Yes, if they are identically distributed, then moment generating function of x should be equal to moment generating function of y, because moment generating function are unique. So if they are unique, then they are should be identically distributed. That is the correct statement. Equation 1 is right. Now they have told us to calculate MGF of z is equals to x plus y. So if we calculate MGF of z t, then we can write it as MGF of x plus y t. And since x and y are identically and independently random variables, here it is written, then we can write it as mxt into myt, which makes our statement number 2 also correct. Then the third statement says that MGF of u is equals to x minus y is this. Now we calculate MGF of u. MGF of ut can be written as MGF of x minus y t. Now this can be written as MGF of x t into MGF of minus y into t. Now minus y can be written as minus 1 into y. So it can be written as minus 1 into y. Now minus 1 here acts as a constant, and we did one property in which Cx can be written as Mx Ct, which is nothing but this can be written as mxt into my minus t, and which is not equals to mxt upon myt, which is a wrong notion, and hence our statement 3 is not correct. So in this question only statement 1 and 2 are correct. This was the question based on properties. It can be directly implied in the question. You don't have to prove them, you just have to tick them the correct ones. Moving forward to the next question. Here mxt, let us take this. Let us take this one. So here they have provided us mxt, and they have told us to calculate this probability. Now in calculating this, let us see what they have given us. Mxt, if I multiply e raised to the power minus t inside and 1 by 10 also inside, we'll be getting 2 by 10 e raised to the power minus t plus 1 by 10 e raised to the power plus t, and minus t will be 0 t. So I can write it as 0 into t plus 4 by 10 e raised to the power 1 into t, 1t, plus 3 by 10 e raised to the power 2 into t. And this is nothing but minus 1 into t. Here we can see that it has been given us the probability, since we know that mxt is nothing but summation of e raised to the power tx into px, summation over x. Now we can see the values of x. Values of x here are minus 1, 0, 1 and 2. And probabilities, corresponding probabilities are 2 by 10, 1 by 10, 4 by 10 and 3 by 10. Now they have asked us, in short, we can write it as probability x is equals to minus 1 is nothing but 2 by 10. Probability x equals to 0 is nothing but 1 by 10. And probability x equals to 1 is nothing but 4 by 10. Probability x equals to 2 is nothing but 3 by 10. These we have been provided to us, and they asked us to calculate this probability. Probability 2x plus 5 is less than 7. Now if I subtract 5 from both sides, we'll be left with 2x is less than 2, and if we divide it by 2, then probability x is less than 1. Now probability of x is less than 1 occurs only in two cases. Probability is x when x is equals to minus 1 plus probability when x is equals to 0. When probability is x is equals to minus 1, it is 2 by 10. When probability is x equals to 0 is 1 by 10. And when we add them, we'll be getting 3 by 10, which is our option number A as your answer. This is the probability mass function on a discrete random variable question. Now moving forward to another question of a similar kind. Here they have provided us with this question. And again I'm writing it like mxt has been given to us as 1 upon 12 e raised to the power 0 into t plus 1 upon 6 e raised to the power 1 into t plus 1 upon 3 e raised to the power 2 into t plus 1 upon 4 e raised to the power minus 1 into t plus 1 upon 6 e raised to the power minus 2 into t. Right? So the values of x have been given to us and probabilities. It is probability when x is equals to 0, probability when x equals to 1, probability when x equals to 2, probability when x equals to minus 1, probability when x equals to minus 2. These have been provided to us, and they have asked us to calculate 8 into expectation of E. Now we know that expectation of E is nothing but summation over x into probability of x. Now we have to sum all the probabilities, which is 1 by 12 x into px. 1 by 12 into 0 plus 1 into 1 by 6 plus 2 into 1 by 3 plus minus 1 into 1 by 4 plus minus 2 into 1 by 6. Now here this is 0, this one is 1 by 6, this is 2 by 3, this is minus 1 by 4, and this is minus 1 by 3. 2 by 3 minus 1 by 3 will be 1 by 3 only. So we are writing here 1 by 3. And if we take the LCM, it will be 12. 2 plus 4 minus 3, which will be 3 by 12, which will be nothing but 1 by 4. This is the value of expectation of x. And in the question, they have asked us 8 into expectation of x. If we calculate 8 into expectation of x, will be 8 into 1 by 4, which is nothing but 2. And hence our option number A is correct. This is the similar kind of question, but the final concept they have changed. They have asked us to calculate 8 into expectation of x. Now moving forward to another kind of question, a similar kind of question, but they have asked us a variance this time. So here also we notice that mxt is equals to 2 by 5 e raised to the power 1 into t plus 1 by 5 e raised to the power 2 into t plus 2 by 5 e raised to the power 3 into t. Now here let us make a table. So here let us see that They have given us the values of x, they have given us the values of px. Okay. Now x has value 1, 2 and 3, and px has value 2 by 5, 1 by 5 and 2 by 5. Now they have asked us to calculate variance. Variance of x. Now we know the formula. Variance of x is nothing but expectation of x square minus expectation of x whole square. Expectation of x has the formula summation over x into px for discrete random variable, and expectation of x square has formula summation over x square into px. These summation are over both of x. So we have to calculate x square as well, which is 1, 4 and 9. So for expectation of x, it will be summation over x into px. So it will be 2 by 5 plus 1 by 5 plus 2 by 5. 2 by 5 into 1, 1 by 5 into 2, which is 2 by 5, and 6 by 5, which is nothing but 10 by 5, and hence it is nothing but 2. And if we calculate for expectation of x square, it will be nothing but x square into px, which is 2 by 5 plus 4 by 5 plus 18 by 5, 24 by 5, which is nothing but 4.8. Now variance of x is nothing but expectation of x square, which is 4.8, minus expectation of x whole square. 2 square is 4, which is nothing but 0.8. If we see here that 4 by 5 is nothing but 0.8, this is 0.2, this is 0.1 something, and this is 0.0 something. So our option number C is the correct answer. That's how we calculate it in examination. Now moving forward to another kind of question. Here we use the different formula that I told you in the last of the properties for uniqueness of MGF. Here they have given us the MGF. MXT has been given us as 1 minus 2t minus n by 2, where 2t is less than 1. Now they have asked you which is the second raw moment. Now for calculating second raw moment, we know that mu dash r is nothing but differentiation raised to the power r x t raised to the power r mxt when t is equals to 0. So here they have asked us to calculate the second moment. So it will be double differentiation with respect to t of 1 minus 2t raised to the power n by 2 when t is equals to 0. T is equals to 0, we have to put at the end. So if we integrate this first time, we'll be getting minus n by 2 into minus 2, and then integration of 1 minus 2t minus n by 2. 1 minus n by 2. And double differentiation, it will be minus n by 2. Here t is nothing but equal to 0. Minus 2, 1 minus n by 2 minus 2. It will be not 1 minus n by 2, it will be n by 2 minus 1. N by 2 minus 1 minus n by 2 minus 1 and minus 2, and this will be 1 minus 2t minus n by 2 minus 2, where t is equals to 0. If we put t is equals to 0, this whole term will be equal to 1. And if we calculate this, this will be minus 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 plus and minus minus plus. This will be n by 2 into 2 into n plus 2 by 2 into 2. This numerator and denominator will get cancelled and we'll be left with n into n plus 2, which is our option number C. That's how you do it. I have just double differentiated it. Firstly, first one time, then secondly, second time, and then I have got the answer. Now moving forward to one of the PYQs that they have asked in our ISS examination. They have provided us with a table. First of all, we'll make the table. So in the table, they have provided us two values of x and y, where y has values minus 1 and 1 and x has values 0 and 1. And they have given us the values inside, the probabilities. So if we say that we have to calculate the probabilities of x, then we will write it like this, which is alpha 1 plus alpha 2. Here it is alpha 3 plus alpha 4. And if we have to calculate the probabilities of y, we will write as alpha 1 plus alpha 3, alpha 2 plus alpha 4. And all of this should be equal to 1. Summation of all of them should be equal to 1. Now they have given us three statements and they have asked us to calculate. Now first statement is expectation of x raised to the power r. If we calculate expectation of x raised to the power r, this is nothing but summation of x raised to the power r into p1x. So if we take it like this, x raised to the power r, 0 raised to the power r into alpha 1 plus alpha 2 plus 1 raised to the power r into alpha 3 plus alpha 4. Here 0 will be, this whole term will be 0 and 1 raised to the power r is 1 only, 1 raised to any power is 1 only. So it will be alpha 3 plus alpha 4. And in the question they have stated it alpha 3 plus alpha 4, so option 1 is correct. So this option get cancelled because it does not include 1. Now we have to calculate for expectation of x and y. If we take it like expectation of x into y, then it will be summation over xy, p1x and p2y. We have to multiply all of them. So first of all, we'll take it like summation over, first of all, we'll take 0 and minus 1. So it will be 0 into minus 1 into alpha 1 plus alpha 2 into alpha 3, alpha 1 plus alpha 3 plus 0 and 1, 0 into 1 into alpha 1 plus alpha 2 into alpha 2 plus alpha 4 plus the next term would be 1 and minus 1. 1 into minus 1 into alpha 1 plus alpha 2 into alpha 1 plus alpha 3. Alpha 3 plus alpha 4, it will come here. Alpha 3 plus alpha 4 plus 1 into 1, it will be alpha 3 plus alpha 4 into alpha 2 plus alpha 4. When you will solve all of this, you will be getting it as alpha 4 minus alpha 3 as your answer, because these two above terms will be 0 only, and here in the denominator there is negative sign and there is one positive sign, so it will be alpha 4 minus alpha 3. So second option is also correct. In the third option, they have told us that to calculate xy raised to the power 2n. Here xy we'll put the power 2n on all of them. And since here minus sign also has power 2, so minus 1 will become positive 1, and in place of positive it will be alpha 4 plus alpha 3 only. And hence our option number 3 is also correct, which makes our statement number D as the correct statement for this question. So let us move forward to another and the last question for today's section. They have given us probability density function of of a random variable y, and they have asked us to calculate the moment generating function. Easier one. We know that the formula for moment generating function is nothing but for a probability density function minus infinity to infinity e raised to the power ty fy dy. Fy they have provided us. So the lower limit is minus infinity and the upper limit is 0 because y is less than 0. E raised to the power ty into e raised to the power y dy. Here this can be written as minus infinity to 0 e raised to the power y 1 plus t into dy. Now we can integrate this. It will be e raised to the power y 1 plus t upon 1 plus t into with the limits minus infinity and 0. If we put the limits of y as minus infinity and 0, 1 plus t comes outside, e raised to the power 0 will be 1, and e raised to the power minus infinity will be 0. So it will be 1 upon 1 plus t. And since y is less than 0, then y is equals to 1 plus t. It should be also equal less than 0, so t is less than minus 1, which matches our option number C. T is greater than minus 1. There might become some error. Here t is less than minus 1. So this is our final answer. We've completed moment generating function today, and I hope that it was a beneficial class for all of you. And if you're still facing any doubts in any other questions relating the topics we have done, then you can ask us on the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best and thank you.